Hello all, welcome to part 3 of the Security Tube GNU Debugger Expert course and certification. In this video, we will look at how to inspect symbols using a utility called nm. Now, before we begin, if you want the PDF slides of this video, as well as the code file being used, then click on the link below, which should probably read download PDF slides for this video and code snippets. And once you click there, you can go ahead and either subscribe to this course by paying $50 for the entire course, or you could just go ahead and tweet using the link here. Follow Security Tube, leave your Twitter ID and your email address, and once our system verifies that you've tweeted, we will send the PDF slides and the code sample files to you. Okay, let's get back to business. One quick point, you need to tweet once every video to get all the concerned material for that video, right? Not once in the lifetime of the whole course. Okay, so what does nm really do? Well, nm lists symbols from object files. Now, here is a sample invocation, nm, and then you give the executable. In this case, this is an elf file. And the output which you see typically is 3 rows by default, 3 columns. The first one is the virtual address of the various symbols. The second one is the symbol type, which you will come to in just a minute. And the third is the symbol name. Now, what symbol types are possible? Well, there are different symbol types. A, or capital A, is basically an absolute symbol. B, or capital B to be specific, is for uninitialized data section, which is this symbol belongs to BSS or is inside BSS. Capital D is initialized data section. N is debugging symbol. T, which means it's in the text section. And U is basically the symbol right now is undefined. Now, the output of nm is a mix of lowercase and uppercase symbol types. Typically, lowercase symbols mean it's a local symbol, while uppercase means it's an external symbol. You can have a look at the man page for nm by typing man nm to get the full list of symbols which are available, right? So you have a bunch of these right here where they start describing them. Okay, so let me actually run nm, and I have, let's say, a debug version. And if you notice, just as we looked at in the slide, you have 3 columns. The first is the virtual address of the symbol. The second is the symbol type. If you notice, this is basically the text section. And add numbers is basically the symbol name, which was one of the functions which we had defined. Now, what are the multiple things you can do with symbols? The whole idea is to be able to quickly analyze the different symbols in an executable. Now, one of the interesting ways is you can actually run nm with the -a option and even grep for a specific function name or a symbol name to be exact. So as an example, what you could do is you could just do a grep and say, hey, add numbers is what I'm interested in, right? And we see that add numbers is basically at this virtual address in the text section. Now, this can come in handy if you can imagine that you have a full directory full of full of executables, object files, etc., and you want to quickly search in which of them you have a specific symbol defined, right? So nm can be applied even by giving a wildcard as the file name, right? Okay. The next thing is to actually look at all of the symbols in sorted order. So what do we mean by that? So you have nm -n, or let's try to run nm without the hyphen first. Oops. And what you would notice is basically that you get, all the symbols which are there. Let's actually run this once again. However, for some of the symbols where probably it's not been resolved yet to the virtual address, there are blanks, things are a bit mixed up here and there. So if you wanted all of this in the sorted order, and sorted here is basically by the address, then you can just run the -n option. In the beginning, you typically get most of the undefined symbols, and after that you have symbols listed with the actual virtual address, right? The good part about sorted is it allows you to figure out the different symbols which are probably there in a specific address space. This can come in handy during exploitation and a bunch of other things. Now, if you want to go ahead and display all the external symbols, you can use the -G option. And this would give you the list of all the external symbols, as you can see here. One of the other interesting things which you can also do is basically tell it to specify the size as well, possible. And let's just go ahead and I think it was capital S. And if you notice, now it's able to give you a little bit more information about the size. So as an example, we have a variable, a global variable called I am a global variable, which if we kind of open up the source code file, you would notice that you have I am a global variable here. And as you can see, basically says that the size is actually 4. Now, you also have size mentioned for add numbers and subtract numbers. I'll leave it as an exercise to you to tell me what this size actually signifies, right? Leave it in the comment section and I'll get back to you whether you're right or wrong. So this is another interesting application. One of the other interesting things which we can actually do is simply go ahead and grep for various symbol types of interest to us. So let's say, now we could use the non-debug version as well, so no real issue here. So let's say grep. Now if you remember the slides, if you want to look at all the symbols in the BSS or the uninitialized data section, well, basically the symbol type is B. So let's just do a quick grep on capital B. And as you can clearly see, we get our symbol I am a global variable. Now, if you consult the source code again, I have another symbol mentioned here called I am initialized global variable, and I've set the value to 20. Now, if we refer to our slides once again, for the initialized data section, capital D is what is used. So we can go back here, replace this with capital D, and let's actually go ahead and run this with all. Okay. Just want to check if I've compiled the program before going ahead and using this. So there is one possible case in which I may have forgotten to compile it. There you go. There you are, right? So apologies, I think I had forgotten to compile it after adding the I am initialized global variable. Okay, fantastic. So now you may notice that I am initialized global variable is basically listed right within D, which is where all the initialized data is. Now similarly, you can go ahead and list all the symbols in the text section, right, which you can see is add numbers, subtract numbers. You have main, three things which we can immediately recognize. And basically, you could probably play around with all of these symbols, look at the ones which are of interest to you, and then try to look at it, right? Now, why is this interesting or important? Well, a lot of times when you're analyzing an executable, even before starting off, you probably want to get a very quick idea of what's there in it, right? Uh, of course, you could have gone into GDB, tried out a bunch of stuff like info functions and all of that, which we talked about previously, but NM gives you an overall idea about a lot of other things, right? Uh, if you basically run NM once again, you would actually notice that it also tells you that the different functions and all of that which are being imported from things like libc, right? They're all undefined right now, simply because this is through an external library which isn't loaded yet. And this can give you an overall snapshot of probably what all is really being called inside the executable and what all is being used, right? And if you kind of notice, you also even have the file name in here, which was probably used to do a compilation, right? So NM gives you a very quick snapshot of probably what to expect inside the executable which you want to analyze. The best place actually is the virtual addresses and things like that, which allows you to quickly even set breakpoints on things which you're interested in. You will understand what breakpoints is and what can happen with them probably in a later video. But take multiple executables, play around with NM, and see what you can find. That's all for this video. Thank you for watching. Hold on, and okay, there you go. Finally, if you want the PDF slides and the code files, either tweet the video or please register for the Sgde. Thank you very much. Have a great day ahead. Bye-bye.